Okay, so what is the rule for the Fibonacci numbers?
You use the previous two numbers in the sequence, you add them, and you get the third number.
Okay, so what would that rule say for our sequences here?
So to get whatever sequence we want, like your 3, you just take your numbers for the first one, numbers for the second one, you add them together.
Okay, so say it specifically what the rule would be here. What are we counting, and what's the rule, we think?
So to get the number, to get the number of good sequences, the sequences that don't have runs longer than 2.
Okay.
For a number n, you want to add the number that you got for n-1 and n-2 together.
Okay, so if we're going to try to count the sequences of length n, of heads and tails of length n, that have runs at most length 2, we count the sequences that satisfy that rule for n-1, and count the sequences for n-2 and add them together. So that's interesting. So why would the sequences that have no runs longer than 2 for length n have any relationship at all to n-1 and n-2?
Well, I guess we can look, let's look at the sequences for 3, 2, and 1 and see if we can see how to get.
That's a great idea.
So 1 is head, tail. 2 is head, 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 tail, tail, head, and tail, tail.
Alright.
And then 3, the ones that work, it's going to be head, head, tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, and tail, tail, head.
Okay, so how do these relate to the ones that came before them?
So you'd either be adding a head or a tail onto.
Okay, yeah. Interesting. So the first thought is maybe we had to add a head or a tail into these.
Yep.
So why don't you draw the line where you think they match?
So, well, obviously, if we add a head and a tail to all of them, we get all the sequences for 3. So not all of these are going to match, but we have adding a tail to head, head gets you this one.
Okay, can you add a head to head, head?
No, because that gets you head, 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 which it doesn't work here.
Okay. So there should be, let your brother see, there's one other obvious one out of those 3. Out of the 3 remaining.
Tail, tail, head. This.
Yeah, so where does that go?
This from here.
Okay.
Draw a line.
Alright. So now we have 4 left to pair with 4. So what's the next thing you want to think about how to pair?
Well, I mean, for these you can add a head or a tail, and you can't get a sequence of like 3. So these you can have head, tail, head here, and head, tail, tail. Both of those work.
Okay. Yeah, and since you don't know which ones work, maybe we shouldn't draw the lines in just yet. Right?
Oh, yeah.
Okay, so that's a good observation that these ones we don't know. But maybe it suggests looking at these ones, which might be more forced. Especially if we're going to be looking at adding 1 and then adding 2.
I mean, getting from here to here?
Getting from here to here.
So I guess here, we have to add sequences of 2 on.
Right.
So for the head, we just can't add head. That would get us a length 3. So, and we already have head tail here, so we can only add tail head and tail tail.
Okay.
And that would get us down to these 2.
Right.
Okay.
And then tail, you can add head and head tail.
Okay.
That gets us down to these two.
All right, so you got a choice of 2 for those two. Is there any particular one of those 2 choices that you think, since you're going back 2 sequences and you're trying to produce a guaranteed sequence from that, what do you think might be the way to go here?
I think you would want to put a tail next to the head so you can't have.
Right, yeah. And you've identified that these are the 2 possibilities. So which one do you think produces a very easy to understand rule?
Probably this one, because
The alternating?
yeah, alternating.
But maybe this one makes sense with the head. I mean,
Okay,
you
well-
add the one that you don't have.
Okay.
So, and that, I guess that kind of works with tail, head too.
All right, so draw those lines in.
Alright. So, head is going to go to head, tail. Tail is going to go to tail, head.
All right, and what's the rule for those? For the sequences 2 before?
So you're adding 2 of the opposite flip that your last letter is.
Okay, and then what does that leave us with our other ones here?
So head, tail goes to head, tail, head goes to tail, head, tail. So that one,
So what's the rule there?
you have to add one of the
The opposite.
opposite.
Okay, so for the sequence at n-1, to produce a sequence of length n, what do you do?
So for n-1 and n-2? Or,
So for n-1,
yeah.
what do you do to get to the n sequences of
You
length
add
n?
one of the opposite of the
Last one.
n
Yeah.
minus 1 term.
And what's the rule for the 2 before?
So you add
2 of the
yeah,
opposite
yeah.
term.
Okay, does that produce does that rule always produce a sequence with runs of no more than 2?
Yes.
Yes,
Because
as
you,
well.
you can't get 3 at the end, and you're working with sequences that already work.
Does it produce all of them?
We think so.
You're taking the ones that work before, and then you're just modifying them slightly.
Yeah. So I guess the ones that work before, you're producing all of the ones that end with a run of 1, and the ones 2 before, you're producing all of the ones that end with a run of 2.
Okay.
So we are getting all of them.
Cool. All right, good work this morning, guys.
Yeah.
Good job. That's a fun little problem.